I often talk about Linux either as a unified operating system or as a unified kernel. But the truth is, the Linux kernel is not a unified thing, where everyone uses or needs the exact same version. That's both the blessing and the curse of our beloved community. When you let people do exactly what the hell they want, they tend to do just that, and you end up with tons of different versions of the same thing. So let's dive into all of these variants of the Linux kernel and also into this segue to our sponsor. This video is sponsored by TuxCare. You've probably heard about them by now on the channel. They're your one-stop shop for making sure that your Linux servers or your workstations are always up to date and secured, with the latest patches with minimal disruptions. Their solutions enable you to automatically apply security patches without downtime or reboots, as well as to extend the lifecycle of end-of-life distributions. They also deliver enterprise-grade support for Alma Linux, a very popular forever free replacement distribution for CentOS 7 users. And it is now super easy to get access to TuxCare's Linux security offerings, as they've just launched online license purchasing. You can now subscribe straight from their website without having to talk to a sales representative or to request a quote. So you can just head over to the website linked in the description and start using their automated live patching solution, their extended lifecycle support service, or their enterprise support for Alma Linux on your own terms. So if your organization uses Linux and you'd like to give any of these services a go, check out all the links in the description of the video. Okay, onto the video. And just a small reminder before we get started, Linux is the name of the kernel. I often use the term Linux to describe the entire community or the entire family of operating systems based on the Linux kernel, because that's easier and just everyone understands what I'm talking about based on the context of the sentence. Apart maybe from a few very well-intentioned people, I guess. But in the end, Linux is technically just the kernel. The thing that has all the drivers and all the subsystems that lets the rest of your operating system use your hardware. It contains all you need to use the CPU, the GPU, the RAM, the disks and everything else, plus all the systems to control all of that, and all the subsystems to allocate the tasks and instructions to this hardware. It's the first program that runs when you boot your computer, and it's the brain of your operating system. Windows has the NT kernel, macOS has Darwin, BSD has, well, various BSD kernels, and on Linux we have the Linux kernel. But as with everything Linux, there is no one single unified Linux version that everyone uses. There are plenty of variants, and so we're gonna talk about them today. Now let's start with the basic version, the generic, stable Linux kernel. This is the one you're most likely using. It's the official Linux kernel, straight from Linus Torvalds and all the kernel developers. The release schedule is not necessarily fixed, but you generally see a new version every 2 to 2.5 months, depending on how long each version takes to be deemed suitable for a finished release. They're generally not supported for very long, often just for a few months after the new release is out. This kernel is the basis for every single other variant, and it sees contributions from people who work at a ton of companies, including Amazon, Microsoft, Google, and a bunch of others. And Linux is very likely the biggest software development project, at least in terms of the number of people who contribute to it. All stable versions of the Linux kernel are numbered in the usual scheme, so major number dot minor number, but they also have really strange code names, some of the best including Holy Dancing Manatees Batman for version 2.6.22, Sheep on Meth for 2.6.35, or just Don't Use for the first release candidate of version 5.12. Now, some distributions tend to slightly tweak these generic versions of the kernel, which might be why, for example, on Ubuntu, you might see a kernel named with a -Ubuntu at the end, because they added a few patches on top of the generic kernel. Ubuntu also has what they call the HWE kernel for Hardware Enablement Kernel. It's generally the same kernel version as what Ubuntu shipped with, but with updated drivers to support newer hardware. Certain kernel versions are also marked as LTS for long-term support. These are versions that will be supported for much longer, up to 6 years, but the Linux kernel project recently reduced that support window to 2 years, but it hasn't been really applied to any version yet. As an example, the latest version published at the time I'm making this video is 6.8. It is not an LTS and it will lose support in July 2024. The current LTS is 6.6 and it will be supported until December 2026, meaning it will have had a bit more than 3 years of support. Future LTS versions will only get 2 years. Although other actors could decide to maintain them for longer, the patches just will not be coming from the Linux kernel project itself. LTS kernels is generally what you'll be using if you use an LTS distro, although that's not always the case. It's what you'll want to pick if your hardware is already well supported with that LTS kernel and you want the most stable experience possible. Now, since most distributions tend to ship their own kernel versions that include non-free software or binary blobs, there's the Linux kernel Libre project, which removes all of that to only ship software and code that is completely free, as in freedom. These generally are released a few hours or days after the official Linux stable kernel version, and they have repositories so you can install it instead of the current Linux kernel you're using. Just know that depending on the hardware you use it on, it might not work well or at all. Some components might not have support at all for certain Wi-Fi chips or Bluetooth chips, or for AMD dedicated GPUs or Nvidia dedicated GPUs. Some of them also require non-free firmware to even use the open source drivers that come in the kernel. So you can try it out, but chances are on some hardware it will just not work as well as the generic Linux kernel. Next we have the Hardened Kernel. It's not an official project per se, it's a kernel version that certain distros ship in their repos, like Arch Linux for example. It is the stable kernel with an additional patch set applied to it to make it more resilient security-wise. It restricts access to certain kernel features, to out of 3 drivers like the Nvidia proprietary drivers, although you can still install those using DKMS. It can hide processes IDs from other users, it can restrict loading certain modules or disable the emergency shell for example, and a bunch of other things. This kernel probably will also break certain things on your system, certain packages will not work, it is generally pretty incompatible with systemd and systemd based systems, so you're basically trading off increased security out of the box for certain things that are not going to work. It's probably best to not use that unless you actually work in the cybersecurity sector and you want to use it to test some things out. Next we have the real-time and low latency kernels. These are meant to optimize how your computer's resources are used by scheduling and prioritizing tasks on your CPU differently. The goal is to reduce the latency between a task being assigned to the CPU and its execution, and it is mainly meant for industrial applications or for audio production. This in turn makes the real-time kernel less efficient for multitasking, and it requires a lot more manual config to be efficient, and applications need to be specifically tailored to take advantage of this specific kernel. For example, Canonical recently announced that they will ship a real-time kernel inside of Ubuntu, but it is not meant for the general public. You need to know what you're doing with this thing. The low latency kernel variants do the same thing, but to a lesser degree. It still lets you preempt some CPU threads, like the real-time kernel, but it isn't as predictable as that real-time kernel. Now here is a pretty big simplification. The real-time kernel is when you want to make sure that every instruction is performed in the exact order that you want, no matter if it slows things down. The low latency kernel is to make sure that every task you assign to your CPU is done immediately after you assign it, at the expense of multitasking performance. And the general kernel is for more throughput. You put it through a lot and you want all of this done really fast, no matter the order or no matter the predictability. And now we get into a weirder variant, the Android kernel, because yes, it is Linux based. The Android kernel is focused on supporting a very specific category of devices, namely phones and tablets, meaning that it has optimizations for these exact use cases, with more power management features, more sleep and wake lock features, and a very different way of handling device drivers, because most manufacturers do not open source the drivers for their hardware on Android, so Google had to implement a more modular approach. It also adds a bunch of systems that only the Android operating system needs, like a communication interface for Android processes to talk to each other, a replacement for the system that kills apps and programs when you run out of memory, or a new networking system that restricts access to the network to certain processes. Since Android is way less general purpose than the basic Linux kernel, because it's meant for smartphones and tablets, not for every single type of computing device, it is obviously not suitable to be run on anything other than a smartphone or a tablet. It just doesn't make sense to try and run an Android kernel on a laptop, for example. Next, we have the Zen kernel. It applies a few fixes and improvements meant to have the best performance and experience for Linux desktop users. It is also packaged as the Liquorix kernel for Ubuntu and Debian and a few other distros, although Liquorix isn't exactly like the Zen kernel. It tends to be more aggressive and get better performance at the expense of resource usage. So basically, they're sort of similar. The Zen and Liquorix kernels bring an improved CPU scheduler to reduce latency, they use a more efficient compression algorithm for the swap space, and they have more improvements to RAM read and write speeds, plus a few other changes. In theory, it should result in better performance than the generic stable kernel, although in their testing semi-recently, Phoronix found that if these differences exist, they are pretty minimal, at least compared to the default kernel that Arch Linux shipped at the time. Another version is the Xanmod kernel, with sort of the same optimizations as the Zen kernel, but a few more on top of that. But it has the same goal. It's improving the performance of Linux systems. The Xanmod kernel seems to get better performance than the vanilla kernels, or at least it did a few years back on Ubuntu, although not by a very significant margin again. Theoretically, the Zen, Liquorix, or Xanmod kernels could give you better performance for stuff like gaming or general desktop usage, but it will very much depend on how you use your systems and the hardware you have in them. Just know that you can install them alongside your current kernels, reboot, pick the Zen or Xanmod or whatever else kernel that you want to try, see if it works, and if it doesn't, you can always go back to your other kernel. You don't have to replace it with the Zen or the Xanmod. You can have them installed side by side. Finally, we have the TKG kernels, and I'm saying kernels because TKG isn't a specific Linux kernel version you can download and use as is. It's more like a build system that lets you choose a few specific patches and compile your own kernel with them. It will let you apply some patches from the Zen kernels or from Clear Linux to optimize for newer Intel CPUs, or you can change the CPU scheduler to something that works better for your own use case, and a few other things like that. It's generally going to be more useful for distributions themselves that want to ship a very specifically tailored kernel for the purpose of the distro, or for users who want to experiment and try to focus on a specific workload without having to change distros entirely. So, the question is, what should you use for your own system? And the general answer for 99% of people will be, use what your distro ships by default. If you want to try out other kernels, you absolutely can. You can add the relevant repos, or you can install these kernels from your distro's repositories, and you can just reboot on that kernel. If things don't work out, you can always go back to the previously used kernel and remove the one that doesn't work. I don't think any of these kernel variants have ever been marked or noticed for being malicious or doing anything suspicious, but some of them are just made by one person or a very small group of people, so you never know what could happen with that. So use them knowing that they're not officially sanctioned by your distribution or that they are just third-party projects in general. In the end, most distributions will ship with the basic generic stable version of the kernel or the latest LTS with a few specific patch sets on top of that, some very specific distros will come with either a real-time kernel, for example distros aimed at multimedia production, or some will come with Xen or Xanmod if they're trying to be like the best gaming distro in the world. But generally, the generic stable version works fine for 99% of use cases, so unless you're very curious, just use what is provided right now in your system. And speaking of your system, if you need to change it, why not take a look at our sponsor, Tuxedo Computers? They make laptops, desktops, and small form factor computers that run with Linux out of the box. They're based in Germany, but they ship to most countries in the world. And basically the advantage compared to buying something that comes with Windows is that you know that the hardware works well with Linux. You don't have to put in some elbow grease and work to make things work after you bought the computer. They have a big range of devices that should cover every need and every price point, ranging from small form factor PCs all the way up to giant gaming towers, gaming laptops, and everything in the middle. They're all very customizable, all the laptops can be opened, repaired, and upgraded. You can have your own custom keyboard layout, your own logo engraved on the lid of your laptop, all those good things. I only use Tuxedo Computers these days. This channel is run on one of their laptops, and my gaming needs are serviced by one of their desktops. So if you need a new computer and you want to run Linux on it, and you want to support a company that actually supports Linux, click the link in the description below and check out Tuxedo Computers. So thanks everyone for watching the video. I hope you enjoyed, and if you did, there are all the usual nice YouTube pleasantries that you can do at the bottom of this video. The like button, comment, subscribe, whatever, notifications, everything, you know how this works. And if you really enjoy the video, there are plenty of links to support the channel financially with a bunch of perks if you become a Patreon subscriber or a YouTube member. So thanks for watching, and I guess you'll see me in the next one. Bye!